Today is going to be lecture 17, right?
जी सर.
Yeah. Lecture 17, let's start. So today's lecture, especially the second part, is very important. So, we have to concentrate. So in the last class, we have not been able to finish everything. We started with imbalanced learning. Imbalanced learning. Basically, the problem was if the data is skewed, if the data was skewed or imbalanced, we face some trouble. Okay. We face some trouble with our algorithmic predictions. That is, our algorithms becomes biased towards the majority class. Okay. So bias towards the majority class, তখন যেটা দেখা যায় যে what happens that performance for the majority class is very high. Okay. But performance in the minority class is actually pretty low, becomes pretty low. And this is a problem. It is a problem because minority class is a very big problem because minority class is more important. Okay. So the low performance here is not actually acceptable. Okay. We usually want both better. We want majority class performance high, minority class performance both high. Okay. আচ্ছা. So that was the problem. This problem happens due to three reasons. One was uh, small. One was a small number of minority class samples. Okay. If there are a small number of samples there in the data, especially for minority class, it is very difficult to recognize the patterns. That's why it creates a problem. Okay. The second problem is due to the imbalance data, class imbalance. Okay, class imbalance. If class imbalance is there, prediction gets biased towards one or the other class. Number three was the class overlap. Okay, class imbalance, class overlap. Overlapping between minority and majority class. What does it mean? Achha, let's look at this scenario. You have these samples here, one class. This is another class. So clearly one class is majority, another is minority, right? Can you see the screen?
Yes sir.
Okay. Respond from time to time. So here the data set is imbalanced. We can see you have the blue ones and the red ones, but is it difficult to classify from the red ones from the blue ones, or is it easy? It will be easy. Easy হবে or difficult হবে?
Easy.
ইজি হবে।
Easy হবে.
Easy. Why?
এর কোনো ওভারল্যাপিং নাই।
Yes, they are separated by a further distance. So you see, since there is no overlap, even even though there is a class imbalance and a small number of samples, still the machine learning algorithm will perform very good. Okay, it will perform excellent because those two different class are separated by a large distance. Okay, so decision boundary is very, if I think of it like arbitrary decision boundary, it is significantly far away from one another. So performance will be extremely high. Okay, very good. So you see, these two problems only becomes more complicated when there is a class overlap. Okay, let's look at another scenario. Okay, now, as you can see, there is a class imbalance. There are a small number of samples, but most particularly, there is a class overlap in the boundary regions. Okay, since there are class overlap, it will be difficult to classify from one sample to another, one sample from another. So that's why the performance will drop and all the problems will become much more complicated. So basically, if we try to summarize, if the overlapping is strong, okay, the imbalance problem increases. Okay. So if there is no overlapping, then imbalance problem doesn't matter. But only if there is overlapping, imbalance problem becomes much more severe. in general scenario, in general, any data set you go for, in real world data set, most of them there are some overlap. So that's why it is considered generally. Okay, most data sets will have some overlap, some degree of overlap. Any question up to this? Any question?
No, sir.
Acha. Now, we have seen different techniques to actually improve the scenario. Acha. There are two different types. One was sampling, data sampling. Okay, that was the one type. So this is changing the distribution, data distribution, data distribution. Okay, we are changing the distribution of the data. Okay, so it can be done in three different ways. One was our offered sampling, one was under sampling, another one is hybrid sampling. We talked about it in the last class. In offer sampling, we increase the number of binary class samples. Okay, so that is when you increase the number of samples, this problem is done because we now have more samples. So a small number of samples problem, pattern recognition problem is improved. So we try to reduce the class imbalance. Class imbalance কমে যাবে. So since you're increasing the ratio, in increasing the number of samples, ratio will decrease, imbalance ratio will decrease, class imbalance will reduce. Achha. So in offer sampling, we have seen some of the techniques like SMOT. Okay, that was the fundamental technique, the most best, considered the most standard performance for offer sampling. And based on this one, there are some modification like borderline SMOT. You have ADASYN, and the basic one that was random offer sampling. Acha. So look at this four types of offer sampling technique. In undersampling, you have random undersampling. We have talked about this one. Then we have seen Tomic link. Okay. Then we have seen neighborhood cleaning and ENN. Okay, এগুলো একটু দেখে নিও সেম জিনিস very simple idea using a atomic link removing one sample. So for instance, if I use atomic link, you will see the blue ones from here, এটা তো ছোট, this decision boundary where you have overlap, এই overlap কি কমে যাবে আর বাড়ে যাবে when I'm using atomic link? Remember atomic link? We try to find two samples, okay, from the opposite classes. If one is minority, another is majority, the majority
কমে
one,
যাবে।
yes, overlap, class overlap will reduce. So this type of techniques are, the goal of this techniques is to reduce the overlap, not balance the data set, but to reduce the class overlap problem. All these things, they try to reduce the class overlap. Okay, they try to fix this problem, not this problem. Acha. Now the last one, hybrid sampling, is just the combination of these two. You will perform atomic link to reduce class overlap and increase and use SMOT to actually add more samples to the data set, or SMOT ENN, SMOT plus ENN. Two popular techniques. Acha. Now, which one do you think gives the best performance out of all these techniques in general? What does it
Hybrid SMOT.
say? Write in the comment section. Let me see the average. Which of all these techniques will give you the best results? Write in the chat. Quickly. SMOT, atomic link, hybrid SMOT. What is hybrid SMOT? SMOT ENN, atomic link. বাকিটা কি নাই? ছুটির দিনে ক্লাস। আচ্ছা, 1 2 3 4 5, বাকিরা কি সব ঘুমাইছে? অনলাইন ক্লাস না হলেই ঝামেলা। আচ্ছা, so among all this technique, SMOT ENN is generally going to perform the best. Okay, ENN is much better than atomic link. ENN actually performs better than atomic link, so SMOT ENN is likely going to give you better performance compared to the other one. Okay, আচ্ছা, so that's your sampling part. করে নিও। Now, cost-sensitive learning. In cost-sensitive learning, we perform something that is called algorithmic level modification. Okay, we do something that is algorithmic level modification. Acha. We try to modify our algorithm. Acha. Uh, what is this or how can we do that? So let's see. Our algorithms that we have used so far, for instance, the logistic regression, think of it like this way. We use the error function. Okay. So in the error function, we try to summarize for every one of them. Actual value minus the predicted value. Okay. Actual value minus the predicted value. And for all the errors that we have, we summarize all those things. So that is basically the total number of misclassification. Total number of Alhamdulillah. Total number of misclassification. And our gradient descent tries to reduce this total number of misclassification. That's the idea. Okay. In this algorithm, try to reduce this total number of misclassification. Okay. That will provide generally the best performance. Now, this is done under the assumption that it is done under the assumption that both class has equal number of samples. Okay. But in practical scenario, we don't have that. So things changes. This one is no longer the best rule. Why so? Let's see. You have a data set, let's say for instance. So you have a data set where the scenario is like this. 100 and 10,000 samples. আচ্ছা, not 10,000 না দিয়ে আমি লিখছি 9,900 samples. Okay. So 100 samples in the minority class, 9,900 in the majority class. So the total number of samples is 10,000. Okay. So 10,000 samples in the data and the imbalance ratio কত? 99, right? Highly imbalanced data set. আচ্ছা. Now, in this scenario, let's say you are trying to make predictions. The prediction is like this. You are making 20 samples. 20 are correctly classified. And among this one, 9,800 is correctly classified. Okay, so total how many correctly classified? 9,820. Okay, so the accuracy of this one is going to be 98.2%. Is it okay?
স্যার
Follow?
স্যার একুরেসিটা স্যার মানে তো স্যার
No.
মানে ইয়া মাইনরিটি ক্লাসের জন্য খুবই খারাপ আসছে স্যার,
হ্যাঁ।
ওভারঅল তো ভালো আসছে।
Yes, overall accuracy is 98.2%, but not for minority majority, not individually. Overall is very poor. Overall is very high. 98,200 divided by 10,000. So I have total this number of correctly classified samples. So accuracy is extremely high. And previous class I mentioned that in imbalance data, accuracy metric is quite misleading. We'll see a little bit later some other metrics. Now, in scenarios like this, another scenario, let's say I have 30 correctly classified, 9,700. So what is there? 900, 730. So the accuracy is 97.3%. Okay. Let's say another one, 50 correctly classified. There you have 9,600. So 96.50, 96.5%. Another one, 80. Okay. It was here. Let's say 9,500. So total number of classic classification to 95.8%. Acha. Now think here in this scenario. This is the accuracy. Which one is the highest accuracy? This one,
স্যার ফার্স্ট ওয়ান।
first one. But which one do you think is the best one?
স্যার লাস্ট ওয়ান।
Last one. This one has the lowest accuracy, but it is looking like this is the best performance. This is the best one, best version. আচ্ছা. And this is actually the best because this is very good at classifying this to this from this. So class specific, if we look at class specific performance, we can see this is better in distinguishing this class from this class. আচ্ছা, but is it translated into the accuracy metric? No, it is not translated.
স্যার
হ্যাঁ, বলো কোশ্চেন।
না স্যার, ট্রান্সলেট করতে পারে না এটা বলছিলাম।
হ্যাঁ, yes. আচ্ছা, so if I look at logistic regression, if I look at the number of misclassification, which one has the highest number of misclassification? This one has 420. This one has 350. This one has 270. This one has 180. So when you are using gradient descent, which one will be, this algorithm will prefer which one? Gradient descent কোনটার দিকে যাবে?
ফার্স্ট ওয়ান।
First one. The values that you have, theta 0, theta 1, theta 2, all will be moved, or actually in gradient descent, the values that we are going to find will be moved towards this one. So is it correct or biased? Biased.
Bias.
It is not appreciating this one, rather it is focusing on that one. So that is the problem with the algorithm, the cost function that we have. Okay, it looks at the total number of misclassification irrespective of the class. It doesn't look at the class-wise specific, but the total number of misclassification. আচ্ছা. So in cost-sensitive learning, what we do, we modify the cost function. Okay, we try to modify the cost function. আচ্ছা, how do you modify the cost function? Let's see. We use a cost matrix. আচ্ছা, what does it mean? This is the predicted ones. This is the actual ones. So try to understand. If actual value is 0 and predicted is 0, is it correct or wrong?
কারেক্ট।
Correct. So should there be any misclassification error, misclassification cost?
নো স্যার।
No. If actual value is 1, predicted value is 1, misclassification cost?
জিরো।
100.
Misclassification cost should be 0 because correct prediction, no misclassification cost. So it is 0, this is also 0. আচ্ছা. Now actual value is 1, predicted as 0. So this one should have some misclassification cost. Okay. Actual 0 predicted as 1, this one should have a misclassification cost, C1 and C2. Right? ঠিক আছে? So these two are actually where we have the misclassifications. Now in usual scenario, this C1 equals to C2 is equals to হচ্ছে আমার 1. This is the general scenario. That's what is the misclassification cost, total number of misclassification. যতগুলো error হবে ততটাই misclassification হবে. So that is our general scenario. But when you have cost sensitive learning, we try to imply an intuition. What is our intuition? Intuition হচ্ছে এরকম. Look, among these two, so think of it like this. So there are two types of error. One error is actually 0, predicted as 1. তার মানে actually the person does not have cancer, but he is predicted as he has cancer. Another scenario is actually 1, ঠিক আছে, he has cancer, but predicted as 0. Okay. So actually positive, but predicted as negative. আচ্ছা, আমি এটা একটু উল্টা পাশে লিখছি। আচ্ছা, সমস্যা নেই, তাহলে জিনিসটা একটু চেঞ্জ হয়ে যাবে। আচ্ছা, অ্যাকচুয়াল অ্যান্ড প্রেডিক্টেড। আচ্ছা, সমস্যা নেই। আচ্ছা, so among these two types of error, this is one type, this is another type. Which one do you think is more complicated?
Second one.
The second one, a person who has cancer, but I am predicting as 0, not cancer. This is more significant. So what is this one? Actual 1, predicted 0, right? Actual 1, predicted 0, C1. So this is more critical, right? So this one is more critical compared to the C2. Is it okay? বোঝা গেছে জিনিসটা? Among these two type of error, predicting positive as negative is more complicated because a cancer patient যদি আমি বলি he does not have cancer, it can be life threatening. So this is more critical compared to this one. So we utilize this intuition. What do? We keep the C2 as 1 cost, but C1, that is actually the minority class. It actually the minority class. Positive means minority class. So minority class misclassification that we have, we increase the weight. Let's say make it 5. Instead of 1, let's make it 5. Are you following?
Yeah.
So what does it happen then? If it is 5 times more error, more weight, that means, look at here, in the first scenario, here you have initially 180, but now you have how many? 5 into 80, right? Because there are 80 error. So 5 times, it will not be considered as 1, but 5 times plus 100 error in the majority class. So what is this going to pass us to 40? So this is going to be 500 now. So the cost is going to be 500 now. Are you following?
স্যার এটা বুঝি
Yes,
না
sir.
আবার দেখো, এখানে টোটাল মাইনরিটি ক্লাসে কতগুলো এরর আছে? 80 এরর আছে। মেজরিটি ক্লাস এরর আছে
Yes,
how
sir.
many? 100. So previously it was 180 because everyone was weight was 1. Now we have
Yes.
used different weight. This one's weight is 1 majority class, but minority class weight is 5 times more. So 580, 400 plus 1, 500. Again, if we look at this one, 5 into 770 plus 200. So 535, 350, 450, 550. This is going to be 550. Okay, let's look at this one. It is going to be 5 by 50 plus 300. So this 525. This is also going to be 550. Okay. So this is 80. So 5 multiplied by 20 plus 400. So it is going to be 500 now. Action. Are you following? Is it clear up to now?
Sir, by looking at this table after changing the values after increasing the weight, how can I understand the contribution of minority and majority class?
আচ্ছা, আমি আসতেছি, বলতেছি, আমি জিনিসটা বলতেছি। So as we have changed the value 5 times more, that means any error on the minority class is now penalized more. Okay, I am using penalty value, more penalty. So any error is now penalized more. So what this happens, you see previously this one has the lowest amount of cost, but now you have seen this is highest, this is lower. Both of them are same, 500 and 500. It has changed a little bit, right? It's still not okay, but changed a little bit. Acha. What if instead of using 5, the penalty value was 5, right? Instead of using 5, if I use 10, তখন কি হবে? চেক করে দেখো কি হবে। Instead of 5 into 80, it becomes 10 into 80 plus 100. So কত হয়ে যায়? 900, right? ঠিক আছে?
Yes, sir.
Now here it is 10 into 20 plus 400, that is equals to 600. আসছে?
Ji, sir.
This is going to be 800. This is going to be 900. Is it clear?
Yes, sir.
So now see, among these 4 value, this one, this one, this one, and this one, which one has the lowest weight, lowest penalty, lowest cost? This one,
Last one. Yes.
last one. So when you use gradient descent, okay, if I'm using gradient descent, which one the algorithm is going to prefer now? Which result?
Last
This
one.
one,
The
this one,
minimum value.
because the gradient descent looks at the lowest cost. So among these 4, this one has the lowest cost. So it is going to try to minimize the cost function. So it is going to update the waist in such a way we get to up to this one. Are you following? So basically what we are doing here is that you see previously both minority class and majority class had a weight of 1. Each misclassification was penalized as 1. Okay, fine. But here what we do in cost sensitive learning, any misclassification of the minority class, we increase the penalty. Let's make it 20 and keep it as 1. So any misclassification of the minority class, 20 times more penalization. That means the algorithm will be very careful in not doing any misclassification for the minority class. Any misclassification of minority to majority class, okay, but any misclassification of minority to minority class, I am getting 20 times more penalty. তার মানে আমার ওইখানে misclassification করাই যাবে না. This way, what we are doing, the bias that we are bias shifting the bias. Originally, the bias was in the majority class. Now, increasing the weight like this, I am shifting the bias towards the minority class. Okay, this way, when you train like this, you are going to get much better results. Are you following? আমার কথা বোঝা যাচ্ছে?
ইয়েস স্যার।
Clear? Is the concept clear? Any question, Karo? Acha. So this is actually the basic idea of cost sensitive learning. We use a cost matrix and increase the misclassification cost of minority class misclassifications. Acha. Now you can ask the question, what should be the cost factor? What should be the penalty factor? So you see, when I used 5, it did not change because it was almost the same. When you use 10, it did change the scenario. If you use 20, it will be even better. So what should be the penalty value? The penalty value is a hyperparameter. Okay. If you look at the scikit-learn library, different algorithm, you will find a weight factor. ঠিক আছে? ওখানে আসবে. You will see in the lab, in lab 5. So the default penalty value, the default value that is used in the scikit-learn is actually the imbalance ratio. And in general, using the imbalance ratio actually provides pretty good performance. Okay, this will give you pretty good performance. So basically, since in this scenario, your imbalance ratio is 99, I'm using a weight of 20. That's why it is very close. If I increase the weight, you will see the difference will be significantly higher. This will be much more appreciated by the algorithm compared to this one. This will be the error for this one, cost error for this one will be extremely high. When you make it 50, that will be like 5 বিশ 100 10,000 হয়ে যাচ্ছে. Are you following? Is it clear? Any question?
ইয়েস স্যার।
Okay, so that's the idea of cost sensitive learning. Basically, you try to use different cost value for misclassification, different penalty, and that is how it is done. Okay, most of the algorithms have this is called weighted algorithm. So in cost sensitive learning, we call it weighted logistic regression. Okay, weighted SVM. This is like because we are using a weight factor, penalty factor. So that's the basic idea. So this is another way, like sampling is changing the data. In cost sensitive learning, we are keeping the data just as it is, but just changing the weight. Both are good, both are good in their own way. Okay, you can use either one of them to get the result. Acha. Any question?
স্যার এখানে ডিফল্ট ভ্যালুটা কি হায়ার, মানে তাহলে আমাদের যে এক্সাম্পলটা দেখালেন ওখানে 99 ইউজ করা উচিত ছিল না?
হ্যাঁ, 90 হওয়া হচ্ছে ডিফল্ট ভ্যালু, হচ্ছে যেটা scikit-learn ইউজ করে আর কি. So it should be closer to that one. The optimal value, you cannot say which one is going to be the best. You have to test. Optimal value will be closer to the imbalance ratio. Okay.
ভ্যালুটা তো যত বেশি হবে তত ভালো হওয়ার কথা না?
না, আচ্ছা, এখানে একটা জিনিস বাদ দিলাম. আচ্ছা, ঠিক আছে. হ্যাঁ. So if I keep increasing the imbalance ratio, keep increasing the penalty value, if it is too high, then the bias will be now towards the minority class. তখন যেটা হবে, ইউ সি, ইফ ইট ইজ টু হাই, সিনারিও এরকম হয়ে যাবে, এখানে তোমার 100টা, এখানে হয়ে গেছে তোমার 7,000. ডু ইউ ওয়ান্ট দিস সিনারিও? ইজ ইট এ গুড সিনারিও?
নো স্যার।
No, because this is perfect, but this is now too many misclassification, almost 3,000. I don't want even that bad, because you see, this is also a error, and this is also bad. Maybe not as sensitive as this one, but it is also pretty bad. So we don't want the classification to be biased towards the opposite class now. We want somewhere in the middle. Okay. So if even in this scenario, this is still the best one. So if you use a too high cost factor, penalty factor, then this kind of scenario will happen. The bias will be shifted now towards the minority class. So we don't want that. Okay. Opposite class bias হয়ে যাবে. So we want to keep it in some way. It is not biased in either direction, but giving you a good enough performance. Okay. Is it clear?
Yes.
Any question? Acha. Now let's move on. Now, second topic, performance metrics. Acha. Performance metrics is extremely important concept. It is, you see, whatever the model we are training, we have to understand the performance very clearly. Okay. So let's say you are doing a task, for instance, you are creating a summary of an article or a summary of a paper. So it is done by, let's say, ChatGPT or আরেকটা নাম জানি কি? একটা নাম কি?
Gemini.
Gemini.
জেমিনি।
Yeah. So it is done by ChatGPT, it is done by Gemini. Now, you want to, like, the algorithm needs to see which one is better. Okay. You want to compare. Is this version better or that version is better? So you need to have a metric to say which one is better. Some way to evaluate the performance, some way of evaluation. Okay. So this evaluation is actually very critical in any scenario, even in real world scenario. Let's say, let's say if I have two students, student one, student two. When you are taking a job interview, you look at different factors. So let's say CGPA is one factor, but only CGPA is not very good to evaluate a student performance. You need to look at, based on the job you have at hand, you need different capability. So for instance, you are doing a, let's say, business job, okay, like a business firm, like this way. So only CGPA doesn't matter. There are other factors. For instance, what's your presentation? Okay, presentation capability. Okay, how nice you can present an idea. Okay, how smooth you can actually speak. So these are another criteria that you need to take into consideration. So performance measures is like this. You want to evaluate the performance of a model clearly. Okay, the better you can do this, the better idea you can actually get at about the model's performance in overall scenario. Okay. Acha. Now, so far, we have two different tasks we have seen. One was classification task. Okay. Another one was regression task. And we have seen some of the performance metrics. For classification task, we are primarily relied on the accuracy metric. Okay. So what is the total number of correctly classified samples overall? So let's say out of 100 samples, if 90 of them are correctly classified, then accuracy is 90%. 80 of them correctly classified, 80%. Very simple idea. And regression, we have used the mean absolute error, mean squared error, okay, things like this for the regression task. Actually, linear regression. So let's look at some other metrics, because this metrics, for instance, the accuracy by itself is not enough. Already we have seen in imbalanced data, this gives you very poor idea of the actual performance. Okay. Misleading idea. So we need better way to represent the measurement. So there are different other metrics as well that we need to understand and we will apply. To do that, we'll use this one. 0, 1, 0, 1. This is your actual, this is your predicted. Okay. Okay. This matrix is called a confusion matrix. Same as this one. Before we use this one for cost matrix. Okay. Now this is called a confusion matrix. This is going to be a little bit confusing. That's why. Acha. Try to understand. So see, if the actual value is 0 and the predicted value is also 0, okay, so 1 means positive, 0 means negative. That means this is going to be called true negative. Are you following?
Yes,
Yes,
sir.
sir.
So actually 0, actually negative, also predicted negative, that is true negative. Actually positive, also predicted positive, that is going to be called true positive. So these are like correct prediction, and these two are misclassification. Now, Which one is which? Actually positive, predicted as negative. So it is called false negative because I predicted negative, but that was false. That's why it is called false negative. And this is called false positive. Actually negative, but predicted positive, but that was false. That is why it is called false positive. So these are our 4 confusion matrix parameters. And using these confusion matrix parameters, we are going to evaluate everything. আচ্ছা, let's see. First of all, we start with our accuracy. Accuracy is equals to true negative plus true positive divided by 4টার যোগফল total. Okay. Now, so total number of samples by correctly classified samples. So if I look at one scenario, let's say this one, 20টা ছিল আর 98টা ছিল, তাই না? Okay. So for that one, we had a scenario 20, 90, 800. এখানে অরিজিনাল ছিল 100টা, এখানে ছিল 9900, তার মধ্যে কারেক্টলি ছিল 20টা. So if we try to create a confusion matrix from here, what will be the confusion matrix? বলো. What will be the number of true negative? কত হবে?
স্যার 9900।
9800. 9800 is correctly classified. So that is the true
Yes,
negative. 20 is correctly classified. So that is the true positive. So false negative means actually positive but predicted as negative. কতগুলো আছে এখানে? Actually positive, predicted as negative. কয়টা আছে?
স্যার 80টা।
80টা. So that is true negative, and here is going to be 100. That is the false positive. আচ্ছা. So try to understand, a math can be given from here. So in this scenario, we will try to see accuracy is going to be then 980/20 plus divided by 10,000. That's why it is 98.2%. Okay. Acha, that's the first matrix that we have. But this is very misleading because it does not give you idea about performance in the minority or majority class. So the second metric that we have is called recall or sensitivity or true positive rate. Acha. This looks at the accuracy of minority class. It looks at the accuracy of minority class prediction. Okay. So what does it mean? That is equals to our actual number of prediction, true positive divided by true positive plus false negative. So that is going to be true positive আছে 20টা plus 80টা. So total হয়ে গেল 100টা. So the recall is 20%. Okay. So everything in percentage. So recall is 20%. So that is actually the performance of the minority class. Is it good? ভালো আছে? No. So the recall is very low. So that's this metric. We actually use this one to understand the performance on the minority class. Okay. So if recall is too low, that means our performance is not good on the positive cases. So the overall algorithm is not doing well. Then you have specificity or true negative rate. Okay. So that is equals to, it is actually the accuracy of the majority class. So that is true negative divided by true negative plus false positive. Okay. So এখানে কতগুলো আছে দেখো, I have true negative হচ্ছে 9800 and here you have 9900. True negative plus false negative, false positive. So what will be the accuracy? 99% something, right? Now the specificity, is it good or bad?
গুড।
Very good, extremely high. So when you have this kind of scenario where sensitivity is very poor, specificity is very high, that is when your say your algorithm is actually now biased. Okay, your algorithm is pretty biased, so you have to look into some way to actually overcome this scenario. আচ্ছা, no, no. So we have recall and specificity, ঠিক আছে? Now we need some way to actually look into a compound matrix. Compound matrix, let's see. So দেখাই আগে balanced accuracy. আচ্ছা, what is balanced accuracy? Balanced accuracy is the arithmetic mean of sensitivity plus specificity divided by 2. So that is going to be your sensitivity হচ্ছে 20%, specificity 99% divided by 2. এটা হচ্ছে let's say almost 60%. Okay, so your balanced accuracy is almost 60%. Is it high? Is it good or bad?
ব্যাড স্যার।
It is average, 60%. Original accuracy was extremely biased, 98%. That was not actually giving you any idea about the original performance. But when you have balanced accuracy, it gives you some idea about the overall accuracy of the system. Okay, but still it does not say that recall is too low and sensitivity specificity is too high. It does not represent that idea. করতেছে ওটা? No. We have somewhere in the middle. আচ্ছা,
স্যার
if I look, হ্যাঁ বলো।
স্যার ব্যালেন্সড একুরেসি কি স্যার কখনো মানে 100%-এর কাছাকাছি যেতে পারে? কারণ স্যার দুইটা তো অপোজিট
যদি
ম্যাট্রিক্স
তোমার
এর
সেন্সিটিভিটি
আমরা গড়
স্পেসিফিটি
করতেছি।
দুইটাই বেশি হাই হয়, তাহলে 100%-এর কাছাকাছি যাইতে পারবে। দ্যাট ইজ দ্য বেস্ট ওয়ে, বেস্ট অ্যাপ্রোচ। Sensitivity, specificity, both
জি
of them are almost close to 100. Okay, balance accuracy will be close to 100. So the
জি
algorithm has to be extremely good in classify. Let's look at another scenario. Your sensitive value, recall value is 0, a specific value is 100. Okay, that means all the samples are classified correctly, majority class samples, none of the minority class samples are predicted correctly. So what is your balanced accuracy now?
50%।
50%. So you see, even the worst scenario, your balance accuracy is showing 50% accuracy, balance accuracy. So it is a little bit still not good. Acha. So if we look at some better geometric mean or G mean, the geometric mean is the square root of sensitivity multiplied by specificity. Okay. It looks at the geometric mean. আচ্ছা, so the geometric mean of this one কি হবে এটার জন্য? কত আসবে? কত আসবে?
জিরো।
0, because it is
জিরো স্যার।
multiplied now. So if one of them is 0, the whole thing becomes 0. So geometric mean is 0. So for this one, it is going to be root over 20 multiplied by 99. কত আসে? Calculator. 20 multiplied by 99. Square root কই?
স্যার 44.49।
0.49. That means
ইয়েস
49%.
স্যার।
Okay.
স্যার 44.49।
আচ্ছা,
স্যার
44%.
45%।
আচ্ছা, ধরো 44%. আচ্ছা, now which one is better, geometric mean or balanced accuracy then?
স্যার জিওমেট্রিক মিন।
Yes, geometric mean is better because it gives a better idea, okay, how much the algorithm is actually doing. So if one of them, out of this sensitivity and specificity, if one of them is poor, the overall performance is going to be poor, okay, because it is a multiplication factor. So একটা খারাপ হলে পুরোটাই খারাপ হয়ে যাবে। Okay, that's the problem. It is actually being created here. If one of them is poor, the whole thing is going to be very poor. Acha. So you want a very high G-mean score, and this is the first metric out of all these metrics. Geometric mean is the best one to look at, one of the best one. Okay, out of this metric, this 5 geometric mean is the best for imbalanced data scenario to give you a balanced overall idea how the algorithm or the system is doing. Acha. Now, তারপর একটু দাঁড়াও। আমি একটু আসতেছি, 1 মিনিট। আচ্ছা, let's see. So we have seen five of the metrics, five different metrics. Next, আচ্ছা, you have precision. Precision হচ্ছে how the algorithm is doing in positive predictions, accuracy of positive predictions. So that is like how many true positive that you have divided by true positive plus false positive. Okay. So precision is another metric. Just look at, just like recall and specificity, precision is another. Number 7 that you have is called F beta score, that is equals to 1 plus beta square multiplied by precision into recall divided by beta square into precision plus recall. Okay. The standard version is called F1 score, that is equals to 2 into precision. Recall মানে sensitivity, same জিনিস, divided by precision plus recall. Okay. So this is F1 score. This is also very good. This is the harmonic mean. The previous one was geometric mean. This is harmonic mean between precision and recall. Okay. In geometric mean, we look at sensitivity and specificity. In F1 score, we look at precision and recall. This is also very good in understanding how the algorithm is overall doing. Okay. আচ্ছা, any question up to now?
স্যার এগুলার কি ম্যাথ লাগবে, মানে এই পার্টগুলার?
হ্যাঁ, এই যে এখানে এরকম ইমব্যালেন্স কস্ট ম্যাট্রিক্স থেকে তোমার কনফিউশন ম্যাট্রিক্স বের করে তারপর সেখান থেকে এই অ্যাকুরেসি স্কোরগুলো বের করে নিয়ে আসতে হবে, বিভিন্ন স্কোর। নাম্বার 8 ইউ হ্যাভ দ্য
স্যার
স্কোর।
এখানে পি কি স্যার প্রিসিশন?
হ্যাঁ,
স্যার এখানে স্যার এফ বিটা স্কোরের স্যার পিটা কি স্যার প্রিসিশন?
প্রিসিজন এন্ড রিকল।
জি স্যার।
নাও MCC score is actually very really good, and this is, you can consider this is the best one. And the equation is a little bit complicated, দেখে নিও। True positive, true negative minus false negative divided by true positive plus false positive multiple by dot 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 সাতটা আসবে, ঠিক আছে? So FCC score is little bit different compared to the previous one. How different? আচ্ছা, so all these previous metrics, 7 metrics, this looks at the overall sensitivity score or specificity score, the percentage, not the actual number of misclassification. Okay. So why does it matter? Let's see. Let's give you an example here. Acha. So 100, and here you have 9,900. You are making 50 misclassification here. You are making, let's say, 7,000. Acha. These are correctly classified. So how many misclassified? 50 are misclassified here. Almost 3,000 are misclassified, right? Now, the sensitivity score for this one is going to be 50%. ঠিক আছে না? And specificity score is going to be almost 70%. Okay. আচ্ছা। Now, if you look at geometric mean বা balanced accuracy, it is going to be, let's say, 60%, something like this. You see, when you're doing percentage, you are looking at the overall ratio. Here you are making 50 misclassification, which is half of them. Here you are making 3,000, which is not half. So this is actually still better. But if you look at actual number of scenario, actual number. Here you are making only 50 misclassification, right? But here the number is 3000. The actual number of misclassification here is significantly high. Although this is like 0, this is 1. That means this is positive case, this is negative case. But still, this is the issue. You are making too many misclassification here. Compared to this one, the number of misclassification is too high. But none of the previous metrics, sensitivity, specificity, F1 score, none of them actually take that into consideration. The actual number of misclassification. It should not be like this, that it cannot think of it like proportionally. No. You need to think of overall misclassification. This one should be lower. This one should also be lower. Okay. Not like 8 or 50 or 8 or 5000 হচ্ছে same. Not like this. Okay. They are not equal. This 50 means you are making 50 misclassification. Half, 50%, but here you are making 50 misclassification, here you are making 5000 misclassification. No, they are not equal. So the actual number misclassification is not taken into consideration. So a very high Gmean score, let's say your Gmean score is very high. If your recall is very high, 90%, this is 90%. Recall, this is a specificity. This means your misclassification, let's say only 2 or 4. This can means the misclassification is 4000. It still can give you 90% accuracy. The positive case is very high, extremely high data set, highly imbalanced data set. So this is, but your geometric mean 90%, very high. So সবকিছু অনেক বেশি high আসবে. But this is does not give you the actual scenario. So the actual number of misclassification is not taken into consideration here. But this metric, MCC, you see true positive, true negative. What is the actual number of classification here? False positive, false negative. What is the actual number of misclassification here? It takes into that consideration. So MCC score is very difficult to get high. If any of them is low, the MCC score is going to drop significantly. আমার কথা বোঝা যাচ্ছে? So to get high MCC score, you have to have good performance here in both of the cases. Okay, so that's why this metric is very critical and very sensitive, very good. To have a high MCC score means your algorithm is performing extremely well. Okay, is it clear? Any question? Acha. The last one you have ROC, AUC. Okay, it is like a graph like this. Here you have true positive rate, you have true false positive rate, recall, and you can get a curve like this area under this curve. Okay, so this is AUC means area under the curve, receiver operating characteristics. So this is also very good. This is a little bit difficult or time consuming to explain, so আমি এটা ignore করতেছি, but remember this was also very good. Usually if I try to rank them to give you some idea, especially for imbalance scenario, go for MCC, then ROC, then Gmean. You need all of them, not just one. Gmean, then হচ্ছে F1 score. It goes like this. This is the best. This is then second, like this way. Acha. Any question up to now? So these are actually the overall metrics that we used for classification task. Okay. Usually we look at 4 or 5 different metrics to compare the performance between two algorithms, two scenario like this, not just one algorithm. The one algorithm will not work. You have to look at multiple of them. বলবে?
স্যার এখানে বিটা কি বলছিলেন?
Beta is just
বিটা জিনিসটা
beta
কি?
is a factor, multiplication factor. ভালো লাগবে না। ক্লাস নেই আচ্ছা, in beta, so you have, think of it like this. So if beta is higher, so if beta 1, beta is equals to 1, this is called F1 score. If beta equals to 2, that is called F2 score. If beta equals to 3, that is called F3 score, like this. আচ্ছা, higher the beta, more priority will be given towards precision of our recall. ওকে, কোনটার উপর বেশি প্রায়োরিটি দেওয়া হচ্ছে সেই জিনিসটা কন্ট্রোল করা হয়। ইউজুয়ালি বেটাটাকে কনসিডারে না নিয়ে আমরা নর্মালি F1 স্কোরটাই নিই। ওকে, দ্যাট মিনস প্রিসিজন এন্ড রিকল আর ইকুয়ালি গিভেন কনসিডারেশন। ওকে, আচ্ছা, now for the regression task we have done the classification task. Regression task we don't have that many, we already know some of them. The measurements in this scenario is much more simpler. So because we have, like for instance, we have the data set like this. Okay, and you try to draw a line here in the middle. and then you evaluate the errors. This is the error prediction errors like this, the distance. That's the basic idea. Okay. Now, based on this one, you can take the absolute difference. So that is called absolute difference for all of them. Eta সবগুলো absolute difference. So no plus minus, only the absolute value. Then take the mean of it. So that is the mean absolute error. If you take the squared version, square of this distance, square of this distance, mean squared error. Okay. Then you can have root mean squared error. Whatever the squared error that you get, take the root over of it, it will become root mean squared error. So that is another one. The last one that we use, that is called the R square value. So R square value is a better one that's called goodness of fit. Acha. So what is goodness of fit? This is a qualitative idea, just to give you idea. So let's say if your R square value is 0.8, that means that line, this line, is able to capture 80% of the variance in the data set. Okay, that means how good the line actually is fitting your data. If it is higher, then that means your data, your regression line is fitting the data better. So if it is poorer, let's say 0.2, that means your algorithm is not performing well. So higher the R square value, better fitted version of the fit. Okay, and this R square value is a extension. It has extension আছে. The article that is provided, it is given there. Right, to study that extension as well. We basically, for regression task, we look at this one, meaning absolute error and R square. That is the best one to evaluate the comparison between the two different algorithms. আচ্ছা, any question? আর কোনো কোশ্চেন?
আর আরওসি এইওসি থেকে স্যার মানে আহ, বুঝবো কিভাবে স্যার এটা ভালো না খারাপ মানে?
So ROC AOC score is like from the best version.
স্যার এটা কি স্যার আমাদের? জি স্যার।
বলতেছি, the best one is this one, যেটা হচ্ছে তোমার স্কোয়ার দিবে, পারফেক্ট এই ধরনের কার্ভ দিবে। দিস ইজ দ্য বেস্ট ভার্সন, দ্যাট ইজ ROC স্কোর হচ্ছে 1। দ্য ওর্স্ট ভার্সন ইজ র্যান্ডম প্রেডিকশন, যদি তোমার এই কার্ভটা দেয়, এই কার্ভ, দ্যাটস ভ্যালু ইজ 0.5। অ্যাকচুয়াল সিনারিও গুলো সাধারণত থাকে এই যে এরকম ভাবে কাছাকাছি, not a perfect square but close to that one. So 0.7, 0.8, the higher it is, the better. The maximum it can be 1. If you have ROC score is 0.8, that means it is a very good prediction. Okay, it tries to compare true positive rate with false positive rate, how it is actually making balance between these two. Okay, বেশি ডিটেলসে লাগবে না, ROC একটু এটার জন্য আলাদা একটা ক্লাসই নিতে হবে যদি ভালো মতো বুঝাইতে চাই। Any other
জি
question?
স্যার।
Okay, so today is up to now. Please write your student ID in the chat box.